Okay, we're going to take a look at the finding the gradient of the trend line for the cat data. And the very first thing that you have to do is grab a couple of points that are on the line that you can get. Now, because I'm using this graph, it doesn't have major lines. It's a little bit tricky to get. It doesn't have any minor lines so that I can sort of estimate between these numbers. So I'm going to have to do a fairly healthy estimation. So I'm going to maybe take a point right on here, and maybe another one somewhere maybe here. Everybody's probably going to choose different points, so everybody's going to get a little bit different because these are estimates, a little bit different gradient. You just have to show that you understand how to calculate it and how to interpret a gradient of this line. So then I'm going to basically figure out what the rise and run is here. And the thing is that I should name this point, and it's definitely 5. I can definitely see that it's 5. Hang on a second. 5, and then I kind of have to estimate. So it's definitely 5, maybe 1.6, maybe. Now, if you do a graph that has better lines and has minor lines, grid lines, then you might have a better chance of getting that nailed a little bit better, but I'm just going to estimate that to be about 5 and 1.6. This one I'm going to estimate to be about 10 and 2.6 or 7, maybe 2.7. So you see that I'm estimating, and that's okay. Now, the rise is going basically from along this axis here, right? It's going from 1.6 to 2.7. So 1.6 to 2.7, if you want to just subtract those values, 2.7 in your head, 1.6 is 11, or 1.1. So that's a difference of 1.1. So that's a rise of 1.1. And then the run, which is from 5 to 10 basically. The run goes from 5 to 10, which is a run of 5. Now we know that, I just switched back to typing, that gradient is rise over run. And so in this case, it's going to be my rise, which is 1.1, over my run, which is 5. Now at this point, it becomes probably quite useful. 1.1, oh, I'm using a mouse, sorry, over 5. That's terrible. I don't have my pen. 1.1. Okay. Now, what's this and what's this? So the 5 is the run. That's the heart rate. That's my grams, right, in grams. And this is my kgs. This is my body weight. And so when I talk about what's on the bottom first and then what's on the top in context. So basically what I'm saying is for every increase of 5 grams of heart weight, there is an increase of 1.5 kgs of body weight of the cat, right? And that's how I interpret it, bottom to top. So you just, although you go rise or run, you do the run first and then the rise. How does X change in relationship to Y? Right? So let's just write that. For every 5 grams increase in heart weight, there is a 1.1 kg increase in the cat's body weight. So I've got it in context, I've got units, and I've explained what my rise and run means. And it's a positive gradient, so your gradient should be positive, and it should show as one increases, the other increases. Now, if this was a decrease, if this was a gradient that went down, right? If it went down, then as one variable increases, the other decreases. And so when you do your talk, you have to show that, right? If it was going down, you would go, well, as heart rate in grams increases, the body weight decreases. And so that's how you show a negative gradient, right? So this would be negative. This is a negative gradient. This is a negative trend, and you have to reflect that the gradient is negative. So we'll try to work an example of that where it's negative, but that's what this particular example is for us.